The Industrial Revolution transformed the world beyond recognition. And today, we still rely on many of those groundbreaking advances, whether we realise it or not. In North Yorkshire, a hands-on piece of Victorian engineering that helped change the way people spent their leisure time.
It's not that easy. There's so much force in this wheel.
There is, more than you actually think.
On a Californian mountaintop stands a collection of buildings that reshaped our perception of the universe.
Without these early pioneers, we would have a much smaller understanding of how the universe works.
And an ingenious German machine that demonstrated to the world the value of a new wonder material.
The invention here was small and easily missed, but this small piece of equipment opened up opportunities that had never been dreamed of before.
Born from the flames of the Industrial Revolution, and once celebrated as pioneering achievements, these are the forgotten stories of the sites that built the modern world. Two small towns on either side of the Atlantic. Both have machines over a century old that moved people in ways they had never experienced before.
Along the coast, there are seaside towns full of old buildings and old piers, but occasionally you see something a bit different, something a bit outside of the norm.
This cliffside contraption is 137 years old and is still going strong.
This is part of the daily and weekly checks we're about to do. It's greasing and oil of the rollers. It's basically maintenance to keep everything running smoothly. Oh, it's remarkable. It really is. Built to last. The Victorians knew what they were doing. They've done a really good job, and I'm quite proud to be part of the history.
Aside from its obvious cuteness, there's a bigger story here. Why would you invest all this time and money into this quirky, wonderful little piece of engineering?
In Pennsylvania, America, there's a ride built 18 years later that helps explain the trend this pioneering cliff lift kicked off.
The engineers that created these rides certainly were trying to get that extra thrill that most other parks don't have. It's a wonderful, wonderful experience, and it brings back thrill ride of yesteryear.
These two sites show us something often ignored when looking back at our industrial past.
It's another side to the Industrial Revolution. It's not just about functionality and productivity and efficiency. It's about having some fun.
Building something like this wouldn't have been easy or cheap. I want to get up close to it and find out how they overcame some obvious engineering challenges. But most importantly, I want to find out why they went to all of that trouble. What was it about this place that made all of that effort worthwhile?
Peter House, one of the lift's operators, knows all about this area's history.
So essentially, they were having fun with this.
Yeah, absolutely. A lot of visitors today may not fully appreciate is that all around us were iron ore mines and steel works, a lot of industrialization going on. So this really was almost like an oasis.
30 miles away was the hugely popular Stockton and Darlington Railway. This was the world's first ever passenger steam train service. And in 1861, a local family sought to open up Saltburn to the masses.
the Pease family. They'd already invested in the railways, and they saw an opportunity. If you could get a branch line to a coastal town, you could develop that area. You could develop leisure activities.
The Pease family wasted no time in developing Saltburn as a new and exciting railway destination. But there was a problem: the steep cliff separating the beach from the town.
For the enterprising engineers of the day, that meant designing a new solution.
More ambitious idea was needed, and that's where the Funicular Railway comes in.
What was built, though, was far more than just a practical A to B solution. It would be a journey few would ever forget.
What they did here was really interesting. It was functional to a degree, but it also offered people a chance to try something they had never tried before.
So how does it work then?
Well, actually, it's very simple. It's purely by water and gravity. We fill the bottom tank of the top carriage, as you see there, that's the black bit underneath it, with water out of that standpipe. And what we're trying to do is make the top carriage heavier than the bottom carriage. And it's the weight of that one going down that pulls the bottom one to the top.
This little railway was a form of entertainment in itself. You can work out how it's doing and what connects to what. And I get a big kick out of that. And the original visitors to Saltburn also did.
With all of that simplicity of engineering, I'd love to see it in action. Can we have a go?
Absolutely. Come with me.
The 63-metre track plunges at a staggering 71% incline to the beach below. It takes skill and experience to ensure a steady descent.
Wow, it's like being on a ship.
So you start by moving the handle behind you and the water starts going on. You're going to put the water into the tank at the bottom of the carriage until it just starts to move. And at that point of equilibrium, the brake comes back on and add 10 seconds. Okay? Brake off is down the hill, brake on is up the hill.
And this is the brake.
And this is the brake. All operated by an old ship's wheel.
This 10-second rule is absolutely crucial. Too little water and the carriage won't make it to the bottom. Too much and it will arrive there dangerously fast.
Let
go. There you go. Now count to 10.
Gosh. 5,
Okay.
6, 7, 8, 9, 10.
Okay, water off. And then brake off, let it go a little bit. Start putting the brake on a bit more, that's it. So it's now coming down, so you now need to take the brake off a little bit. This is you cycling. This is you putting the brake on and taking it off.
It's a bit stop-start.
It is, until you get used to it. And then brake right off at the end, just to make that last little movement.
It's not that easy.
Not that easy, is it?
No, because you really feel the weight.
Absolutely, and it does require some strength to go with it.
For someone in the 19th century, this was an opportunity to experience technology in a whole new way.
Being in this carriage, you get a real sense of what it must have been like back then to be in something like this. You know, it's cutting edge, it's exciting, the views are absolutely stunning. And the steepness of this slope is really apparent from where I'm standing. I mean, it feels like you could nosedive down to the beach. Here we are, just pulled in, and didn't take long, less than a minute.
A lasting answer to the dilemma of the steep cliff had been found, and it was so much more than just efficient engineering.
What's really great about the cliff lift is this idea that, yes, it had a function, and some great engineering was involved. But it also gave the passengers an opportunity to really enjoy the novelty of being in such a gorgeous place.
Getting a train to the seaside for a day of pure enjoyment is something we now take for granted.
We all like going to the seaside. The fresh air, the views, the feeling of escaping everyday life. But it hasn't always been like that. It was only advances in engineering that's opened up the seaside.
A railway line combined with a thrilling attraction became a new winning formula.
Places like this, which had a ride and an experience that people could dive into, started off a trend.
But it wasn't only in Britain. America soon took on this idea of end-of-the-line entertainment, and they gave it their own unique spin.
I get so excited every time I see Leap the Dips. This used to be something that every amusement park across the country had. Knowing that this is the last of its kind, that you can't find these anywhere, this brings such great joy to me.
As you walk up to it, you've got that sense of anticipation. You already can feel that excitement. It is about pulling you in with that major, major ride, with that big top experience. And there it is, Leap the Dips. Are you going to ride it? Are you too scared to ride it?
This 12-metre-high structure has towered over its visitors for more than a century. It's 443 metres of twisting tracks, offering them a high adrenaline ride.
As you can see, this is a primitive amusement device. There's no seat belts, there's no restraints, no over-the-shoulder restraints, no lap bar restraints. Just basically get in, sit down, the operator gives you a little push, and off you go.
In contrast to Saltburn's dramatic seaside beauty, it's not immediately obvious why Lakemont Park was built here.
These sites look very different, but actually at the heart of it is the same reason.
Places like this one were heavily tied into the rail companies that got you there.
This was what was known as a trolley park. It was at the end of the tramway, but why not put something there that it actually attracts people to take the tram and go and see it?
Lakemont Park was the magnet drawing the crowds to the end of the line.
Built back in 1894 by the Altoona and Logan Valley Railway to help bring ridership on the weekends when normally the trolley would not be running.
Suddenly, with the expansion of transportation, you didn't have to wait for fun to come to you. You could go to where the fun was.
So they started building with mainly like pavilions, music venues, such as a gazebo, but they also started adding amusement rides.
The Leap the Dips roller coaster arrived in 1902, and it was an instant hit.
So if seaside resorts could attract people by showing off natural beauty, these man-made attractions like a roller coaster, which combine engineering and experience, could be a draw in and of themselves.
Saltburn was functional, getting people from A to B, but Leap the Dips, now that's moved you into a different class, hasn't it? That's about chasing adrenaline, choosing to pay good money to be scared.
As with the Saltburn Cliff Tramway, the engineering on display here is wonderfully simple.
Right now we're underneath the lift hill of Leap the Dips. Compared to the newer, more complex, higher tech roller coasters, this one utilizes a simple chain lift mechanism to bring it up, using a 30 horsepower motor to pull the car all the way to the top.
After the car reaches the peak, technology gives way to basic scientific principles.
As you disengage the chain at the top of the hill, you are now following Sir Isaac Newton's law of gravity as you follow through the course of the track, freewheeling along the course.
When you see this thing in action, it's brilliant. It's like a runaway minecart.
You'll bounce off the boards back and forth a little bit, and then you'll drop over the little dips and drops. And your car, at times, will literally pop up and leap the dip, so to speak. Just like riding a sled down a hillside, there's no brakes until you get to the bottom.
The first roller coasters gave people a taste of adrenaline like they had never experienced. And soon, they wanted more.
Look at theme parks today, the crazy rides you can go on.
Other parks may build the world's tallest, longest, fastest, craziest roller coaster, but the one record that they can't take away from Lakemont Leap the Dips is the world's oldest roller coaster.
The Saltburn Cliff Tramway and the Leap the Dips roller coaster reveal an often overlooked side of the Industrial Revolution.
It's really easy to get sidetracked by the heavy engineering aspect of it, the production of the global exports, that we forget all the fun stuff.
There's so many great moments in history that museums are set for, but that's fine. However, being a part of your entertainment, your day-to-day living, Leap the Dips is definitely a part of that.
This cliff lift really represents two major things: a need for advancement and progress and ingenuity, but also our very natural tendency to just want to be able to enjoy life.
On the edge of Los Angeles towers Mount Wilson, and sat atop its peak is a facility that holds an incredible secret.
Not many people know this is here, even though it's been here over 100 years. There are buildings up here that were unequaled in their time, feats of engineering, performing science that revolutionized the world.
Inside one of these buildings is a huge scientific instrument.
The only manufacturing factories big enough to machine the components were shipyards at the time.
This is one of the most influential telescopes in the history of astronomy.
What makes this place so important is the way it fundamentally changed our understanding of the universe.
Even the greatest minds of the age came here to seek proof for their theories.
Einstein visited rather like a pilgrimage.
But before this site reached its legendary status, the mountain itself had to be conquered.
This mountain range doesn't look easy to navigate now, and it certainly wasn't then.
Building these giant telescopes wasn't easy either. Many complex engineering conundrums had to be solved.
This isn't just about scientific discovery. This is about human industry and ingenuity.
To overcome the challenge, engineers, scientists, and construction crews would all be pushed to the limit and beyond. The creation of this awe-inspiring complex started with an appreciation of this area's unique geography. and the efforts of one pioneering man.
George Ellery Hale is an interesting character. We can kind of call him an astronomical entrepreneur.
As a prolific founder of observatories, Hale was looking for a potential site outside of Los Angeles when he made an important discovery.
Hale scouted Mount Wilson in 1903, and at first he thought the terrain was too tough, too difficult. But then he passed the cloud line, and he was so surprised to see that the conditions were excellent.
This location had something special for people who were interested in viewing the skies that no other place at the time had.
Tom Meneghini has worked at the observatory for over 2 decades.
In the San Gabriel Mountains, this is the first land rise off the Pacific Ocean. The air has come thousands of miles across the Pacific Ocean, and this is the first piece of land they hit. And the air that hits here comes up and rolls over the mountain very smoothly and very slowly. It's called laminar airflow. That makes it very stable, and it's good for observing stellar and sky objects.
When stellar observations first started here in 1904, relatively little was known about the extent of the universe. Mount Wilson's first telescope, though, focused on something more familiar: the sun.
In the 19th century, there was a booming interest in astronomy. What fueled this interest was solar eclipses.
While far smaller than the mountain's later telescopes, this device proved that the observatory was ready to make serious contributions to the world of astronomy.
This is the Snow Solar Telescope. Its sole purpose is to look at the sun. It is the oldest permanent solar telescope in North America, probably the Western Hemisphere.
It analyzed the light from the sun by splitting it into different beams. As successful as it was, the observatory was just getting started.
Hale didn't just leave it with the sun. He had much, much greater ambitions. And his first one was to try and install a 60-inch telescope on top of the mountain.
The popular telescopes of the day used lenses to focus light. But Hale and his team wanted to pioneer a new direction.
What they were trying to do was expand on lenses. Hale realized that to go any bigger, he couldn't do it with a lens, that astronomy would have to go to mirrors to get more light-gathering power.
This 60-inch mirror required huge supporting components. But getting it all up here was going to be a serious task.
To anyone who was just walking up this slope, this incline is impressive. So imagine having to move heavy equipment up such a steep hill. It's extremely difficult.
A toll road had been built, which is a lot better than what had been there before, but it still needed purposely built vehicles to move the necessary machinery up to the top of the mountain. But this toll road was hazardous.
Some of the most cumbersome parts were those that allowed the telescope to move smoothly.
Well, we're in the 60-inch telescope right ascension gear room. This is the mover of the telescope to track and to move to objects east and west. It's a very fine-tooth gear for a gear this size.
Hale's powerful reflecting mirror design produced photographs showing what appeared to be stars in other galaxies. But the conventional wisdom of the day suggested there was only one galaxy. It would take Hale's next project to find the truth.
Hale was never satisfied with just resting on his laurels. He always wanted to push the capabilities of the technology at the time.
Not content with 60 inches, he wants a 100-inch reflecting telescope. That's huge.
no one was sure that a 100-inch reflector could even be made. Could the glass keep its correct shape within a few millionths of an inch?
A French company that made the glass for Crystal Palace and the mirrors at Versailles took on this ambitious task.
The factory there was the largest in the world. It was the only one capable of melting that much glass, which was 9,000 pounds is its weight.
But their first effort was deemed a failure.
The problem with it was it had bubbles. They had to do 3 pourings for that much glass. It made a layer cake type of structure, and it trapped bubbles inside each successive layer or waves. And when it was shipped here, it was rejected.
Several attempts to eliminate the bubbles followed, but they all cracked, fractured, or just disintegrated.
The fact that a glass lens without bubbles led to shattering, this helped to give us an idea of exactly what those bubbles were doing.
Those bubbles may have actually strengthened it or led to some stability in the glass that the other ones didn't have.
The initially rejected mirror ended up being the one they installed.
So here we see a universe, a constellation, if you will, of bubbles in French glass.
Engineering innovations were forcing the telescope parts to get bigger and bigger. But the track to the summit was still tiny. Hale's team had to be creative and courageous to get the job done.
The team had adapted a brand new Mack truck to help carry some of the heavier girders for the new telescope. One day, it careened over the edge at Buzzard's Roost.
It was a chain drive truck with slick non-pneumatic tires that slid off the road because it didn't have traction. The ground soil was like this, loose, and it was a steep embankment. The driver lost control.
The assistant driver and Walter Adams, who was one of Hale's scientific team, managed to jump from the truck before it fell. But the driver was not so lucky, and he fell 300 feet. Miraculously, no one was injured.
The vehicle was ruined. It was overturned and crashed into a tree. It's a good thing it hit that tree. It would have gone down another 1,000 feet.
Over 10 years after Hale initially had the idea, the 100-inch telescope finally went into operation on the evening of November the 1st, 1917. Little did anyone know the earth-shattering discoveries it was about to make.
One of the first people to use the 100-inch reflecting telescope was an astronomer called Edwin Hubble. Like everyone, they believed that there was only one galaxy, and that was the Milky Way.
Edwin Hubble, with his telescope, found a spiral nebula.
This is a star that pulsates in a predictable way. But the more intriguing part of the discovery was how far away it might be.
Astronomers weren't sure whether it was within our own galaxy, was a forming solar system, or what.
There were theories that some stars were further away, but that's exactly what they were. They were just theories.
Thanks to the pioneering work of a scientist called Henrietta Swan Leavitt, Hubble could work out the star's distance from Earth, and the answer was astounding.
He established that there were other objects outside of the boundaries of the Milky Way. And so that was the discovery of the universe.
This was hugely groundbreaking. I mean, you could almost compare it to Copernicus and the removal of the Earth being at the center of the solar system.
The discoveries, however, didn't stop there.
Hubble and Leavitt's work also proved that the universe was expanding.
And this was of particular interest to one of the world's greatest minds.
Albert Einstein was elated to hear of Hubble's work. Einstein's theory of relativity implied that the universe was either expanding or contracting. However, Albert Einstein himself rejected his own theory in favor of the idea that the universe was static.
Einstein was right, and he thought he was wrong. That's why he was wrong.
Einstein called his adherence to the old idea my greatest blunder.
The 100-inch was used by many of the greatest astronomers of the 20th century, and the new discoveries kept coming.
It allowed them to discover things such as the size and shape of the Milky Way, the difference between red giants and red dwarfs, the difference between nova and supernova. The list goes on and on.
The Mount Wilson Observatory used the science and engineering foundations of the 19th century and built a complex that showed the world we were just getting started in understanding our place within the cosmos.
I call this the Sistine Chapel of Astronomy. The 100-inch telescope was designed to go deeper into the universe than any other instrument on Earth. It forever changed the nature and character of astrophysics and understanding of our universe.
Hidden beneath a wooden building in the Harz Mountains of Germany is a revolutionary machine very few people know anything about. The building's discreet and quaint exterior gives little away as to what it might contain. It's only inside where it becomes apparent there's more here than first meets the eye.
Inside are wooden and metal structures that ascend through the floors. This simple solution to a problem has become such an integral part of engineering all around the world.
To get to the bottom of this mystery of how it just changed the world, you have to go down into the depths of this mine.
This is the Samson Pit silver mine. And this device has been key to its operation for nearly 2 centuries. But its legacy reaches far beyond the realm of mining.
This invention is very small and easily missed. However, it really opened up so many possibilities that they never dreamed of before.
This silver mine has come a long way since its humble beginnings over 500 years ago.
Da gab es nur ganz wenig Energiequellen früher, nämlich die Muskelkraft von Menschen und Tieren. Das war alles sehr mühselig und teuer. Und dann entdeckte man irgendwann dann doch die Wasserkraft.
The beating heart of the mine was once this massive wooden water wheel.
Das Wasser kam von oben drauf und die haben dann die Tonnen mit den Erzen nach oben gezogen oder Materialien auch nach runter gelassen. Praktisch eine Fördermaschine mit Wasserkraft betrieben.
Hemp was the strongest rope they had, but it was far from ideal. It soon became a hazardous material to work with.
The hoisting ropes that were made of hemp began to wear and tear, particularly as they went deeper and deeper. There was more failure that led to not only the damage of the mine, but also loss of life.
So the race was on to find a solution to the unreliable hemp rope.
Despite years of experimenting with other materials, the conundrum still couldn't be cracked.
Also nachdem man immer Hanfseile genommen hat, begann man irgendwann mit Ketten zu fördern. Aber auch die Ketten hatten ein großes Problem, denn sie wurden aufgrund der Tiefe der Schächte immer schwerer. Sie brachen, weil sie waren handgeschmiedet und irgendwann gab es so viele Unfälle, dass man wirklich überlegte, den Bergbau im Harz einzustellen.
Finally, in 1834, mining expert Wilhelm Albert made a crucial breakthrough.
He essentially copied the wounded strands of the hemp rope by using wounded strands of iron. By splicing ends of iron together, he got longer and longer strands, which became stronger as they were wounded together.
This revolutionary material became known as wire rope.
Hier haben wir eines der alten Drahtseile. Dieses ist hier 1835 aufgelegt worden, also ein Jahr nach der Erfindung. Und das ist so haltbar, dass es bis 1923 genutzt werden konnte. Und ich glaube, man könnte es sogar heute noch benutzen. Es ist in einem ganz hervorragenden Zustand.
Hoisting ore was suddenly no longer such a dangerous game. But as one issue was solved, another was raised.
As the years went by and the mines got deeper and deeper, another problem became just the sheer effort it took for the miners to continue to climb up and down the ladders.
It took 90 minutes for the miners to climb down and an exhausting 150 minutes to climb out again.
This was the journey on ladders, the equivalent of going down a 66-story building.
Wer schon mal 10, 20 oder 30 Meter auf Leitern geklettert ist, der weiß, dass das unheimlich anstrengend ist. Ich selbst habe es mal 360 Meter gemacht. Ich war dann 3 Wochen praktisch malat, kaputt, müde.
With all this exhaustion, serious accidents were frequent. A new approach was badly needed if the mine was going to remain open. Once again, it was wire rope inventor Wilhelm Albert who saved the day.
Albert worked with the mine manager at the time to come up with a new way to transport miners from the bottom of the shaft back to the surface again. He created something they call the man engine.
Und wir sehen jetzt hier vor uns die Fahrkunst. Es bewegt sich immer parallel, gegenläufig auf und ab. Und immer wenn die Richtung wechselt, dann sind die Tritte und die Griffe parallel nebeneinander. Wir können das jetzt hier schön sehen.
As the ladders move up and down, the miners step across from one to the other, so the ladder takes their weight and some of the effort of the climb. The movement of the ladder effectively carries them down one step and then the other.
This system simply would not have been possible with hemp rope. It simply would have snapped.
Thanks to the man engine, extracting precious metals from the depths of the earth could now be done more efficiently than ever.
Previously, all of the exertion and energy would reduce the productivity. But now, as a result of this new invention, they increased their productivity by perhaps 2/3.
While the man engine was a huge success, it was the wire rope that it relied upon that had the biggest impact on the modern world. And in the 20th century, one man would take this idea to America, where it would take on a life of its own.
Each tower has what are called shivs. The shivs are what the wire rope runs on. And at the top is a bull wheel that turns the cable around and back downhill. And at the bottom, the same thing.
This is another historic machine built to transport people. But this time, the destination was skyward.
We tend to think of industry and leisure as quite separate things, but some canny industrialists realised that the two could work very well together in the 20th century.
This is the Boyne Mountain Ski Resort. And hidden here is another twist in the incredible journey of wire rope.
We're at the bottom of the Hemlock Lift at Boyne Mountain, the very first chairlift ever built in the world. When you're doing the first of anything, there's going to be a lot of unknowns. One of the unknowns is once you had this chair onto the cable, how fast could it go? How do you pick up people at the bottom?
Wire rope made it out of the mines and initially spread into the cargo shipping industry. And this is where chairlift inventor James Curran found inspiration.
Curran had experience on banana boats. They would have a cable with hooks running continuously, where they were either unloading the boat to the shore or loading the boat up in South America.
Curran thought he could replace those banana hooks with chairs.
To test its feasibility, he attached a chair to the side of a pickup truck. The skier wearing roller skates practiced jumping on and off as the truck drove past slowly.
Part of the design which was never in question was the use of wire rope.
Well, the wire rope, without it, you wouldn't have a chairlift. You know, rope, fiber rope, hemp rope, or any of that would never be durable enough to hold up a chair and a couple of human beings.
The rope for this pioneering chairlift was supplied by a company founded by John Roebling, designer of one of the most impressive structures ever built using this magic material.
John Roebling took the ideas from the mines in Germany over to America, where he began to implement and use these ideas in his own designs.
His growing reputation meant that in 1867, he was asked to work on one of the most important bridges of this age, Brooklyn Bridge.
The Brooklyn Suspension Bridge proved just how spectacular the application of wire rope could be. 65 years later, the Hemlock chairlift reminded the world that wire rope still had a role to play in creating radical structures never seen before. More than 100,000 cars continue to use the Brooklyn Bridge daily. The Hemlock chairlift still transports people up Boyne Mountain today. And incredibly, the MAN engine has kept its usefulness too, by serving the staff of a hydroelectric power plant that has taken over the now dormant mine.
Hier wird in 190 Meter Tiefe noch Strom erzeugt. Und die Mitarbeiter müssen hier heute noch mit der Fahrkunst von 1837 dort runterfahren. 190 Meter geht es mit diesem Apparat nach unten. Also eine ganz alte Technik, die heute noch benutzt wird. Ja, Glück auf. Das ist der Bergmannsgruß. Und man wünscht es beim Reinfahren, beim Rausfahren, damit alle wieder glücklich nach oben kommen.